You know, something absolutely huge is happening in space right now. It's being driven by two massive interconnected forces. First, you've got artificial intelligence, which is basically giving satellites their own brains. And second, there's the incredible rise of new space powers. And there's no better example than India's amazing journey to the moon. So we're going to connect these dots and see how they're shaping a whole new era of competition, commerce, and discovery way beyond Earth.
Just look at this number for a second. Over 100,000. By 2030, that's the projection for how many satellites will be circling our planet. To put that in perspective, we're at about 7,500 today. This isn't just growth, it's an explosion. It's a traffic jam of epic proportions waiting to happen. And it means the old way we manage space, it's just not going to cut it anymore.
For decades, pretty much every satellite was tied to Earth by this, digital umbilical cord. You had teams in ground stations constantly watching, sending commands for every little move. But you just can't do that with tens of thousands of satellites. It's impossible. The only way forward is a total shift to autonomy, where the satellites themselves are smart enough to make critical decisions in real time.
So how does this actually work? Well, this is where AI really steps in as the hero of the story. It's the secret sauce that makes managing this incredibly crowded and complex environment possible. AI is literally becoming the brain of the whole operation. The key technology that makes this all happen is called orbital edge computing. The easiest way to think about it is that satellites are becoming self-driving cars for space. Instead of just being dumb relays waiting for instructions, they have powerful computers and AI right there, on board. They can process tons of data and make decisions on the fly without that long, dangerous delay of waiting for a command from Earth. So what's the number one job for a self-driving satellite? Not hitting anything. And that process is a constant, super fast loop. First, the AI systems are detecting and tracking everything. We're talking over 35,000 large objects and millions of tiny, dangerous debris fragments. Then, predictive algorithms are constantly running the numbers, predicting if any of those things are going to cross their path. And finally, if a threat is flagged, boom, the satellite moves itself, adjusting its orbit to get out of the way. All of this happens in an instant with zero human input. And if you want to understand the incredible scale of this, get a load of this number, 85,000. That's how many times SpaceX's Starlink satellites had to automatically dodge a potential collision in just 6 months. That's thousands of near misses being averted every single month, all by AI. There is no way human operators could ever hope to manage that. It's just not possible.
Okay, so we have this new world of smart, autonomous spacecraft, and there's no better case study for this new era than India. Their journey to the moon with the Chandrayaan program is just a masterclass in how to do high-impact science and cost-effective engineering. What's so impressive about India's approach is how methodical it's been. Each mission builds on the last. It all started in 2008 with Chandrayaan-1, which completely changed how we see the moon. Then in 2019, Chandrayaan-2. And while it's landed and make it, the orbiter was a huge success, and it's still sending back amazing data. And all of that led to 2023's incredible, historic landing of Chandrayaan-3 at the South Pole. Now they're even planning to bring samples back. Let's just go back to that first mission for a second, because what it found was a total game changer. Using a couple of NASA instruments it was carrying, Chandrayaan-1 gave us the first definitive proof of water molecules on the moon's surface, and it found strong evidence of water ice hiding in those dark polar craters. Before this, everyone thought the moon was bone dry. This one discovery is what really kicked off the new global race to the moon. Then came that amazing landing by Chandrayaan-3, which put the first ever scientific instruments on the ground at the South Pole. This is what scientists call in situ science, doing the experiments right there on the spot. It immediately found sulfur, which was a big surprise. But maybe the most shocking discovery came from its heat probe, which measured a wild 70 degrees Celsius temperature drop just 10 centimeters, like 4 inches, below the surface. That tells us the lunar soil is an incredible insulator, which is absolutely vital information if you're ever planning to build a habitat there. So India's success is a huge deal, but it's also part of a much bigger story. The whole world is now racing to the moon, and specifically to its South Pole. This isn't just about planting flags and getting bragging rights anymore. This is about resources. It's a brand new kind of gold rush. And the absolute focal point, the epicenter of this entire new space race, is right here, the lunar South Pole. And the reason is actually pretty simple. Some of its deep craters haven't seen a single ray of sunlight in billions of years, and scientists are convinced they hold huge amounts of water ice.
So why does a bunch of frozen water on the moon matter so much? Well, because water is everything in space. It's the key to the whole future space economy. You can turn it into breathable air and drinking water for crews, obviously. But here's the real kicker. You can also split water into its basic components, hydrogen and oxygen. And what's that? It's the most powerful rocket fuel we have. The moon could literally become a gas station for missions heading to Mars and beyond.
So, when you have this intense competition for resources, with all these new players, we're talking nations and private companies, all heading to the same spot, well, it brings us to the final piece of this puzzle. You need a clear set of rules for the road. Which, of course, leads to the big question, right? In this new gold rush, who actually gets to make the rules? How do we make sure that space stays safe and sustainable for everybody? And on this, India is a really fascinating model for how to move forward. Their 2023 space policy was a landmark moment. It officially ended the government space agency's monopoly, throwing the doors wide open for private companies and startups to get involved in everything. This also frees up their agency, ISRO, to focus on what it does best, cutting-edge R&D and those ambitious, deep space missions.
At the same time, India is also looking outward. By joining the Artemis Accords in 2023, it basically raised its hand and said, "We're in." They've committed to a common set of principles for peaceful and transparent exploration. It's a really important step in building some kind of global agreement on how we're all going to operate on the moon. So this is where we are. We've got AI-powered satellites dodging each other in orbit. We have a global rush to the moon to tap into resources that could fuel our expansion into the solar system. And we have the beginnings of a framework to try and govern it all. The technology is moving at lightning speed. The real question is whether our ability to work together can keep up. Can we make sure this next giant leap is one we take together?